Hello friends, in the previous lecture we have seen that how to solve system of linear equation and how to find the value of h and k if we are given the system of linear equation. Now today's lecture we have to define what do you mean by equivalent form of a matrix and row reduced equivalent form of a matrix. Okay, so let us define equivalent form. Let us define equivalent form of a matrix. Okay, let us define equivalent form of a matrix. Now, rectangular matrix in equivalent form. So, what do you mean by equivalent form of matrix? Rectangular matrix. Rectangular matrix is in equivalent form. Rectangular matrix is in equivalent form if it has following property. If it has following properties. So first one. So what is the equivalent form of matrix? A rectangular matrix is an equivalent form if it has following property. First property is all non-zero row. First property is all non-zero row. All non-zero rows are above the zero rows. Okay. What is your first property? All non-zero rows in a matrix are above the zero rows. And second property becomes each leading entry of a row is in column. Second entry is each leading entry of a row. Second property is each leading entry of a row is in column to the right. Each leading entry of a row is in column to the right of each. Second is each leading entry of a row is in column to the right of the leading entry of the row, to the right of leading entry of the row. Okay. What is the second property? Each leading entry in a row, if you have your matrix in that row, each leading entry of a row in a column. Okay, this leading entry also present in a column to the right of the leading entry of the row. Okay, and your last property is all entries in the column below the leading entry are zero. Third property is all entries in a column, all entries in a column below the leading entry are zero. All entries in a column below the leading entry is zero. Okay. What is your third property? All leading entry in a column. Okay. If you have a matrix, in that matrix, all leading entry in a column below the leading entry as zero. That means in the column, leading entries below elements are zero. So if you are to consider the example, suppose this is the matrix, that is 3 by 3 matrix. Your first row becomes 1 0 2. Your first row becomes 1 0 2. Second row becomes 0 minus 1 3. And your last row becomes 0 0 8. Okay. Your last row is 0 0 8. So this is your matrix is in equivalent form. Second one, suppose we have given matrix 1 0 0 0 2 0. Okay. This is also matrix is in equivalent form. What is my equivalent form of matrix? A rectangular matrix is in equivalent form if it has following property. It's all non-zero rows are above the zero rows. Okay. In your first example, these three are your non-zero row. Suppose there is fourth row is 0. So these all non-zero rows are above the 0 rows. 0 rows. Okay. These all these three are non-zero row. In that, in your second example, these two are your non-zero. But there is some row, third row. We can write this also as 0 0 0. Okay. And all these two are non-zero, are above the 0 rows. Okay. Second property is each leading entry of the row. In your first row, leading entry become 1. Okay. So each leading entry in a row, in a column to the right of the leading entry of the row. So in that your first row leading entry is 1. Okay. And in that first column leading entry also 1. In second row leading entry is -1. Right. In second row leading entry is -1. So what is second row say that leading entry in the row, this leading entry is -1 to the right of. So leading entry in that column. So this leading entry -1 in your second column. This leading entry in your second column is the right of the leading entry of the above. So this -1. Okay. This -1 is right side of the leading entry in the first row is 1 in the first column. This is your right of side of the second row. Okay. Similarly, in your third row, leading entry is 8, and this leading entry 8 is right to the leading entry of the second row. In your second row, leading entry is -1, and in third row, leading entry is 8. Okay. This matrix is in equivalent form. That means what is the equivalent form? So this matrix, what is the equivalent form? In that your matrix, all below the diagonal entry becomes 0. What is my equivalent form? Your matrix, when your matrix is in below the diagonal entry are your 0. That means given matrix is your upper triangular matrix. Okay. If matrix is in upper triangular form, then this matrix is your equivalent form of matrix. Okay. In second one, this also matrix is upper triangular form, and third row becomes 0. You can assume that this third row is 0 0. This matrix below the diagonal entry are 0. Okay. This matrix also is in equivalent form. So what is the equivalent form matrix? That is if matrix is in upper triangular form, so matrix will become equivalent form. Okay. So next point, what is meant by row reduced equivalent form of matrix? So next point is row reduced equivalent form of a matrix. Next point is row reduced equivalent form of a matrix. Next definition: row reduced equivalent form of a matrix. That is, in short, row reduced equivalent form of matrix. That is RREF. That is a row reduced equivalent form of a matrix. So what do you mean by row reduced equivalent form of a matrix? So let us divide. If a matrix in equivalent form, what do you define? If a matrix is in equivalent form, if a matrix is in equivalent form, satisfies, if a matrix is in equivalent form, satisfies the following properties. Satisfies the following properties. Satisfies the following property. So your first property becomes. So your first property is the leading entry in each row is non-zero is 1. So what is your first property? Your first property is the leading entry in each non-zero row is 1. The leading entry, first property is leading entry in each non-zero row. The leading entry in each non-zero row is 1. What is your first property? The leading entry in each non-zero row become 1. Okay. This is your first property for row reduced equivalent form. And your second property becomes each leading one is the only each leading one is the only each leading one is the only non-zero entry in its column. Each leading one is the only non-zero entry in its column. What is the row reducible form? If matrix is given is in echelon form, and if that echelon form satisfies the following property. What is first property? The leading entry in each row is non-zero. Each leading entry in each non-zero become 1. In your echelon form, leading entry is 1 or any number, right? That is any non-zero number. But in the row reduced echelon form, each leading entry in each non-zero row must be 1. For row reduced echelon form, each leading entry in each non-zero row become 1. And second property is each leading one is the only non-zero entry in its column. That means, suppose you want to take example, okay? So that is 1 0 0 0 1 0 and 0 0 1. This is your echelon form of matrix. What is the echelon form of matrix? In the first row, leading entry each non-zero 1. In the first row, leading entry is 1. Okay? So each leading entry in each non-zero row become 1. And second property is each leading one is the only non-zero entry in its column. Okay? In your first column, in each column, leading entry must be 1. So in your second column, leading entry is 1. There is no other leading entry. In second column, leading entry is also 1. There is only one leading entry. In third column, leading entry is 1. Okay? For the first row, leading entry is 1. Second row also leading entry 1. And third row, leading entry 1. So that means we get the matrix is in identity matrix. Okay? This is your row reduced echelon form of matrix. Okay? Suppose there is one more example. That is 1 2 0 1 0 1 2 0 and remaining these rows are 0. Okay? This matrix, suppose this matrix, what is order of that matrix? There is 2 rows and 4 columns. Okay? And is it matrix is in echelon form? Is it matrix in echelon form? Yes, it is always echelon form. But this matrix is also in row reduced echelon form. Why this is matrix in row reduced echelon form? Because in the first row, leading entry is 1, and below that entry are 0. This is 0, and there is also 2 rows. Third and fourth is obviously 0 0 rows. That is 0 rows. Okay, containing all 0 elements. So below that entry are 0, and your first column leading entry is 1. Satisfy both property. First property is each leading entry in is non-zero 1. Yes, first property satisfied. And second property is each leading one is the only non-zero entry in its column. In your first column, each leading entry 1 is only one element in that first column. In your second column, in your second row, leading entry is 1, right? This is 1 is right out of the first column. So right side of this one, yes, first property satisfied. Second property is each leading one, this leading one is the only non-zero entry in its column. In your second column, there is only one leading one. There is no other leading one. There is 2. This is not 1. So second property is also satisfied. So both properties satisfied. This is also your example of echelon form, right? That means we will reduce this matrix into upper terminal matrix. Okay? If there is 1, then second property is not satisfied. Because this entry in your second column, leading entry is 1, is only 1 in that your second column. So this is your example of row reduced echelon form. So next we will define what is meant by pivot position of a matrix. Okay? Next point, what is meant by pivot position of a matrix, and also we have to define pivot column of a matrix. Okay? So let us define what is meant by pivot position of a matrix. So let us define what is meant by pivot position So what do you mean by pivot position of a matrix? Okay. So let us define a definition. A pivot position. A pivot position in a matrix. A pivot position in a matrix capital A is a location. A pivot position in a matrix capital A is a location in a matrix capital A that contains in a matrix capital A that contain or that correspond to leading one a pivot position in a matrix. A pivot position in the matrix capital A is a location in matrix A that corresponds leading one that corresponds leading one in the row reduced equivalent form, that correspond the leading one in the row reduced equivalent form, okay. It is called as pivot position of a matrix. What is the pivot position of a matrix? A pivot position in the matrix capital A is a location or a position in the matrix that corresponds to leading one in that row reduced equivalent form. That means if we are given a matrix and we are going to do this matrix in row equivalent form, suppose we are given matrix 3 by 3 and this matrix we have reduced in row reduced equivalent form. So suppose row reduced equivalent form is 1 1 0 0 1 0 and 0 0 1. This matrix is in row reduced equivalent form. Okay, this matrix in row reduced equivalent form. So in that row reduced equivalent form, so leading one, so in your first column leading one is present in which position? Leading one is present in 1 1 position. Okay, and in your second row leading one is present in 2 2 position, right? And in your third row leading one is present in 3 3 position, right? That is A1 position, A2 position and A3 position. So what is the pivot position? Pivot position means your leading entry is present in that position. Okay, what is the pivot position? Your leading one is present in that position. This position is called your pivot position. So what is your pivot position? So pivot position in your above example is become 1 1 2 2 and 3 3. Okay, so what is the pivot position? Pivot position become a position in that your row reduced equivalent form matrix. So leading entry is present in that position. This is called your pivot position. Okay, so this is your definition of pivot position. Now we have to define what is my pivot column. Okay, so we have to define what is meant by pivot column. Okay, so what is my we have to define here pivot position. Pivot position means in matrix A, if matrix is in row reduced equivalent form, in that your row reduced equivalent form, so leading one is present in that position. So that position is called as your pivot position. Okay, suppose there is also 0. Suppose there is also 0. So this matrix is also in row reduced equivalent form, correct? In that your row reduced equivalent form, there is leading one is present in 1 1 position and 2 2 position. Then your pivot position become only 1 1 and 2 2 position. Okay. Now let us define what is meant by pivot column. Okay. Let us define new definition. What is meant by pivot column of a matrix? Okay. So pivot column of a matrix capital A is a column. So a pivot column of a matrix capital A. A pivot column of a matrix capital A is a column that contains a pivot position. What is the pivot column of matrix? Pivot column of matrix is a pivot column of a matrix capital A is a column. Okay. Pivot column of matrix capital A is a column that contains a pivot position. So in your example, so pivot position become 1 1 and 2 2. So in that your pivot position, so pivot position is present in first and second column. So what is your pivot column? So pivot column means 1 and 2. So what is your pivot column? Pivot column of matrix is a column that contains pivot position. So we have that only pivot column. So pivot column become pivot position present in that matrix, and that column is become your pivot column. Suppose This is your 1 0 0. This is your 0 0 and 0. Okay, this is your matrix. Okay, this matrix is in echelon form. Yes, in your first row leading variant is become 1 and your second row is become 0 rows. So all non-zero rows are above the 0 rows away. So pivot position is present in which position? So this is your 1 1 position. This 1 1 position is your pivot position. P dot P. So this 1 1 position is pivot position, and the pivot position is present in first column. Right? Pivot position is present in your first column. So your pivot column is first column. This is your P dot C. P dot C is pivot column. What is pivot column? So first column is your pivot column and pivot position is 1, 1. This is your example of pivot column. Pivot column is your column of matrix that contains a pivot position. This is called your pivot column. So in the today's lecture we are going to discuss all these parts: pivot position, pivot column, and rectangular form of matrix, and echelon form of matrix, and row echelon form of matrix. So I hope all parts you have understood. So in the next lecture we are going to see the example on that pivot position and how to do this matrix in row echelon form. So thank you.